So when I have this dynamic memory array, which was allocated by new, you should kind of develop some sense that when I write it like this, hard-coded, this may be a little bit dangerous, because what if they allocated only 2 elements in this array? Then clearly an attempt to access the 3rd element would be a memory access violation, and I will be in trouble. So that's why you would probably never hard code anything like this, like I did, but most likely you can, maybe write a for loop which will use some kind of index starting with 0, because all arrays are 0 based, and then say that index is less than the element count, right? Less than element count, and then increment the index and index, right? And then do something like this in a loop, right? So instead of any kind of hard coding, you would like to stay safe and instead use like an index to refer to your dynamic block of memory elements, and you can even use this index to populate each individual element with the values sequentially counted 0, 1, 2, 3, 4, 5, right? So this is more appropriate approach to do something like that. Let's actually build and just see if there aren't any issues with this build. Let's see. Undeclared identifier. Did I? Oh, dynamic array and dynamic memory. Oh, I see. I just, I should have said dynamic array, not dynamic memory. I wasn't paying attention. Okay, so this should be dynamic array. I apologize for misspelling it. Okay, so anyway, so this kind of like demonstrates this lowest level of usage for dynamic memory that you would typically see in a C++ code, right? So there's other library functions available in C, like malloc and free, that correspond to new and delete, but this is an example of a C++ program. And before we wrap up this segment on dynamic memory allocation of our presentation, I would like to give you an alternative to this. What most people would do today, instead of using new and delete, there is a much better approach to this. I will now keep this here as a comment, just in case if I need to go back to this. In fact, I need to say element count and enter element count like this. But most people today would say include, and that's what you should do in your normal life. Don't need that caps. Use a vector, which is dynamic memory array. And with vector, what we can do is we can simply say std vector, vector of integers, for instance, and I can call it still dynamic array. I can call this dynamic array and create it, and I can even specify the parameters that I want, for instance, this many elements, right? And I may want to initialize it with something. I can initialize them all with zeros, for instance. And this will construct a dynamic array in such way that you don't have to use delete, right? When you create a dynamic array, it simply becomes a local object which manages memory for you. And by the time we say return, dynamic array will be actually deallocating any memory that it has dynamically allocated without any kind of problem and without any memory leaks. So in the same exact code, I can copy and paste to use it, right? It supports the same notation, square brackets with an index or subscript, which specifies which element of the dynamic array to use. So just to let you know that this is a much better choice than new and delete. But since we're just studying pointers and lowest level that you can possibly go with at doing memory allocation, we're covering new and delete, and I'm just showing you new and delete in action that you can have. Sometimes you really need that. Sometimes you really need to control when precisely you create new objects, and that's sort of like an advanced topic, but then you have no choice but say new. And there are some other helper objects which can automatically destroy. Like for instance, there's another facility in the library that's called unique pointer object, which basically manages the memory for us. So this is where I would like to stop, just to give you ideas that memory can be allocated dynamically, because to this point multiple times I was telling you that there's this heap memory segment which basically is a placeholder for dynamic memory allocation, and now you know that yes, indeed, it can be done. Of course, when we use vector, right? When we say vector of integers, that's the notation, and we create this object again. Wherever it populates, needs to allocate space for, say, 100 integers, of course, it internally uses the memory manager facility, and of course, it's allocating those, anything that it gets allocated dynamically is placed on the heap, basically in the dynamic memory area. So I just wanted to show you some of these things very quickly, to show you that you can also, if you wanted to create just an empty dynamic array as a vector, then you could populate it dynamically by saying dynamic array. There are multiple ways to insert elements, but pushback basically inserts an integer just like this, and this would be a very typical way of populating, say, using a loop to dynamically populate this dynamic array, which is a vector of integers. This is a standard library object, and it is parameterized by the type, and pushback is a function that you can use to say, I would like to insert this index, which is like 0, 1, 2, 3, 4, 5, into that array of dynamic array of integers, right? So just to give you an idea, this is nothing that I'm actually going to ask you on any quizzes, or I'm not even asking you to remember it. I just conceptually want you to know that there are direct facilities in the programming languages that deal with dynamic memory allocation. And so vector is an example of such memory allocation. And of course, new and delete is what vector does internally. It's implementation somewhere in that library file. You can say open document, and it's actually, of course, a real header file that has all this stuff written for us, that does new and delete and so forth and so forth. So I am going to wrap up this segment and now switch over to presentation of structures. Any questions?